Hello everybody, I decided to make a video. I've got this electronic load laying around. It has been with me for more than an year. It is 150 watts load, but you can improve it and make it even 600 watts, 300, 450 and 600. In order to do this, you have to add 3 more transistors. Here are some connections for those, but it's not about this in this video. It's enough for me to have a load for 150 watts only for my purposes. Sometimes I use it for testing lithium-ion batteries, and sometimes I use it for testing power supplies of laptops, mostly laptops, so it's about 100 watts. Now I'm showing you that the load is working, as was expected actually. The point of this video, I want to put it in some case. By the way, this battery is not good. It's not supplying enough current and the voltage gets down, so that should be wasted. Also, I ordered a meter like this one, analog one, with a shunt resistor. I wanted to put it in my lab power supply. The video I showed you before, that's the shunt, but there was not enough space in my lab power supply for this emitter, so I will try to put those two devices in one case, like this one. I got it for free. Man gave me a power supply which didn't work, and there was no reason to try to repair it, because those power supplies are not used anymore, and it wasn't Dl24, so we cannot make a lab power supply out of this. So this is the idea. I'm gonna put the LCD like here, and somewhere I'll put analog emitter somewhere, and I'm gonna show it to you how I did it. Also, I want to replace the wires. These are too rigid for me and too short, so I cut a hole, a window for an LCD with a Dremel. Let's put it, and it fits nicely. Afterwards I will glue it, and for this I decided to put it on the back side of the case like this, because I didn't want to cut through the backside panel, because it's not a really easy thing to do. But here I just can use a wire cutter and cut the hole. Here I use the special pattern from the same power supply, as you can see. I don't have to be too precise for cutting the hole, just approximately like this. That should do. Almost cut it. There is only one left, and just by using the cutters like this I can make a hole. You can make a hole. That's it. Let's try it, and I'm gonna make some more cuts off camera, and after this, as you can see, everything fits perfectly. There are 2 screws. I'm gonna secure it with nuts, obviously, and 2 washers. Just like this. And that should do the job. The reason why I bought this emitter, because this is quite precise, especially compared to Chinese emitters, voltmeters that you can buy for a few bucks. Those are very unprecise, and I'm gonna show you in the end of the video, and to compare the precision of this and Chinese emitter that I used in my lab power supply. So I connected it, and of course we should add some hot glue, which is a mandatory thing in all DIY projects. As to say, must have ingredient. You cannot call it DIY if you don't use hot glue. Because I'm kidding, but it is used very often. Okay, this one is done. Next is LCD for electronic load. It already goes with these things, which is obviously not enough for holding LCD in place. Maybe if you have cut a very tight hole in a plastic case, maybe it would be enough, but not in my case. I have some space in between, so I put it like I wanted it to be, like this. And after that, of course, must have ingredient from all the sides of the LCD, like so, to make it rigid and immovable for centuries to come. Like so. Okay, I didn't want to cut or to make any holes on the bottom of the case, so I always have some alumina material, and I wanted to put this piece like so to secure it with bolts or screws, and after that I'm gonna make some holes in it and to secure the PCB itself. 2 screws would be enough, in my opinion, because there won't be any mechanical load on the PCB. I removed 2 of those legs. It's not gonna short out because there is a plastic thing, this one, on the back of the board. Okay, that's how it looks like at this stage. I connected those 2 wires for powering on the PCB. Here is the connector. Here I put a plastic thing just not to allow the wires to rub against the metal. Here is the shunt that covers this hole. Now I'm gonna solder the wires. By the way, those are wires from the power supply itself. I'm gonna use 3 of those for output to the load. Now I'm gonna make 2 holes, cut thread in those holes and to secure PCB. I don't have to be precise, just something like here and here. That's it. And those are the tools for the thread and the holes. Now it's secured. Let's put wires. I've got to solder those, test it, and put a cover. Okay, this one is soldered. Those are the wires I made from the wires of power supply. I think that's enough for me. I like it more than the original. Also, I have always 12 volts power supply from a battery and from the power supply at my bench, and I have those two wires. So I didn't want to put any batteries inside. It's not needed for me. I don't use it too often. That's how it looks like. The final result. And now we are gonna test. There is a power supply on the right side. This ammeter is precise at this power supply. I've checked it, and as you can see, I put 5 amps, 10 amps, and the ammeter on the left is showing the same values. As you can see, 5 amps, and they are the same. And that's the meter and voltmeter I put in my lab power supply. Now let's check how precise it is. As you can see, I put 10 amps and the meter, the real value is 7.5 amps. So as you can see, 12 amps, and it's not even close to 10. You must understand, I'm not promoting you to buy an analog ammeter and put it like this. I'm just bought it myself and wanted to use it somewhere. That's why I put it in here. Okay, now let's test the load itself. I think to test the batteries is not interesting. I've showed it to you. The more interesting for me to test some laptops power supplies, which is the case why I actually did it. Because sometimes people give me power supplies and they output the right voltage, but if you load it with 3 amps, probably it would go to protection mode or the voltage would be too low. So this load is quite useful for those purposes. As you can see, it outputs 19 volts. Let's put 4.7 amps, which is the value of the power supply output, just like this, and start. As you can see, the fan starts to spin. Voltage dropped to 18.8, which is acceptable. Current 4.7, 88 watts. So it's okay. This power supply can be used for its purposes. So that's actually it for this DIY project, as you can call it. I wanted to make some holes on the backside, but then I decided it's not needed for my loads. 100 watts for a short period, it's not needed. So I'm gonna keep it like this, and I'm gonna use it sometimes. Maybe somebody would find it useful, make something like this or similar. That's it for today. If you like it, give it a like, and see you next time. Goodbye.